Assalamualaikum and hi everyone. Glad to see you again. For instance, a person has 2 hands and 10 fingers, or H2F10. The empirical formula for that would be HF5. The ratio of finger to hand is 5:1. Similarly, consider benzene CCH6. Both the number of carbons and the number of hydrogens can be divided by 6. So the empirical formula is CH. The empirical formula tells us that the ratio of carbon to hydrogen is 1:1. There is 1 hydrogen atom for every C atom. It's important to note that more than one substance can be reduced to same empirical formula. To stretch our hands-finger analogy, we might have a 2-handed person or an alien with 3 hands and 5 fingers on each hand. The empirical formula of each this would be HF5, since in both cases the ratio is 5 fingers per hands. For chemical example, consider benzene and acetylene. We can see that for benzene, the molecular formula of CH6 reduced to an empirical formula of CH, since there is 1 hydrogen atom for each carbon atom. Similarly, the molecular formula acetylene C2H2 also can be reduced to CH. Since 2 different molecules can have the same empirical formula, an elemental analysis is not sufficient to completely determine the identity of a molecule. Chemists have developed a wide variety of other qualitative analysis techniques, such as spectroscopic method. Empirical formula can be defined as the simplest ratio of all elements in a molecule, whereas molecular formula is the actual number of atoms of each element in a molecule. Now, let us try to solve this problem together. Oxalic acid is usually used to clean off blood and rust stains. It contains of 2.24% hydrogen, 26.65% carbon, and 71.08% oxygen by mass. The molar mass of oxalic acid is 90 gram per mole. Determine the empirical formula and molecular formula of oxalic acid. Okay, first of all, we have to look at the information given in the question. Okay, in the question, it's already given to you the percentage of carbon, hydrogen, and oxygen, and also the molar mass of oxalic acid. Therefore, you have to refer to the table of relative atomic mass for the atomic mass of carbon, hydrogen, and oxygen. Okay, for the first step, what should you do? You have to assume mass of a sample is 100%, equal to 100 gram. Okay, right? So therefore, we know that the mass of carbon is equal to 2.24 gram. Mass of hydrogen, 26.65 gram. And mass of oxygen is 71.08 gram. Okay, for the second calculation, you can draw a table like this to calculate the empirical formula of oxalic acid. Okay, from the previous calculation, we already know the mass of hydrogen, carbon, and oxygen. Therefore, you can substitute all the values into the table. The mass of each element in gram. Next, calculate the moles of each element. Mass over molar mass. From the calculation, we can clearly see that the moles of carbon is the smallest among all. Therefore, the simplest ratio calculation, each of the number of moles for each element must divide with the number of mole of carbon. Therefore, the empirical formula of oxalic acid is CHO2. Okay, based on the question, it's already given to you the molar mass of oxalic acid. Therefore, you have to find out the value of N. So, from the calculation, value of N is equals to 2. Okay, molecular formula, we can calculate by substitute value of N equals to 2 into the empirical formula. Therefore, the molecular formula of oxalic acid is C2H2O4. Do you know how does a combustion analysis of unknown hydrocarbon is carried out? In a combustion and analysis experiment, a hydrocarbon sample is heated in a stream of oxygen gas. As the sample burns, water and carbon dioxide is pushed through a series of chambers with materials that absorb each of respective product. The chambers are each wedged before and after the combustion to determine the mass of each products. Now, let us move to the second example. Compound A consists of the element carbon, hydrogen and oxygen. The complete combustion of 4.624 gram of the compound A yielded 6.557 gram of carbon dioxide and 4.026 gram of water. Determine the empirical formula of compound A. As we can see here, the mass of carbon, hydrogen and oxygen is not directly given in the question. Therefore, the first step that you have to do is to calculate the mass of carbon, hydrogen and oxygen by using all the information given in the question. For example, the mass of carbon can be calculated by the mass of carbon dioxide divided by the molar mass of carbon dioxide times molar mass of carbon equals to 1.7883 gram. Same thing goes to the mass of hydrogen. Mass of H2O divided by molar mass of H2O times molar mass of hydrogen. Therefore, the mass of hydrogen is equal to 0.4473 gram. For the mass of oxygen, we can calculate as follows. Mass of compound A minus mass of carbon minus mass of oxygen. Mass of oxygen is equal to 2.3885 gram. For the next calculation, you can draw a table like this to calculate the empirical formula of compound A. Right, from the previous calculation, you already calculate the mass of carbon, hydrogen and oxygen. Then you can substitute in the table the mass of each element. Okay, next, calculate the moles for each element. Mass over molar mass. Okay, from the calculation, we can clearly see that the smallest number of mole is referred to the mole of carbon. Therefore, the simplest ratio calculation, each of the number of mole of each element must divide with the number of mole of carbon. Therefore, the empirical formula of compound A is CH3O.